So this one's slightly different. In fact, I would say that all of these are easier than what we were doing over there, okay? Because we're not doing any matrix multiplication first. But I started off with matrix multiplication because it's the type of, it's the most common way of combining matrices together, okay? So I gave you, for example, an actual example. In fact, I gave you 3 examples on Friday. Okay, I started with sandwiches and the cost of each sandwich and the number of sandwiches which are sold per day. And we combine those together using matrix multiplication. I think I also gave you one in terms of like number of supplies which a classroom needed and the cost per supply. And also gave you like number of workers per day and the number of hours and the cost which each worker brought to the company. So I brought all of those matrices together using matrix multiplication because it's the most useful way of combining matrices together. That's the reason why I started with that one. Okay? These ones, I would say, are just purely there for convenience. Like we've done matrix multiplication, why can't we add or subtract matrices together as well? They're not as widely used in the real world, but we still need to be aware of how to combine them together. Okay? So C plus D should just simply be, in fact, if I write out C plus D, so C will be 8, 1, 4, 8, 2, 0, so I'm going columns, and D will be 4, 7, 9, 8, 10, and 1. Well, if I'm adding them together, how do you think I'm going to do that? Yeah, I just add corresponding elements together, right? So I just do 8 plus 4, which is 12, and then 4 plus 7, which is 11, and then 2 plus 9, which is also 11, and then 1 plus 8, which is 9, 8 plus 10, which is 18, and 0 plus 1, which is 1. I just simply add corresponding elements together.
But we don't need dimensions here.
Ah, that's a good question. Do we need dimensions here? Yes, no. Okay, so you're saying they're different. What do you mean by different?
Like it's a 3 by 2 by 3.
Okay, so that one's a 2 by 3, good.
Yeah, plus,
So what's this one?
it's a 2 by 3.
Okay, so they're the same, aren't they? They're the same dimensions.
It's a 3 and 2, like. No?
Okay, so when we're doing this thing over here, we checked the inner 2 dimensions to make sure that we could multiply them together. But here now, what do we need instead? We're not interested in the inner 2 dimensions anymore. What are we interested in instead? Fantastic. We have to make sure that they are the same dimensions. Okay, because you think about it, how did we add these 2 things together? We added corresponding elements together. So if we had, say, for example, an extra row over here, like there'd be no extra row here to add them together with. There'd be no corresponding elements to add them with. So we need to make sure that there are the same elements or the same position of elements in each matrix. So the dimensions have to be the same. Is that okay? So we basically need the same size matrix in order to add or subtract. Whereas over here, it was slightly different, slightly more complicated. Okay? But you're happy, it's just intuition. Okay? You're just adding corresponding elements together. Okay? All right, what about D minus C then? D minus C. So we're taking D, which is 4, 7, 9, 8, 10, 1, and we're subtracting C, which is 8, 1, 4, 8, 2, and 0. Okay? What do you think we're going to do here? Yeah, we're just going to subtract corresponding elements together. Now just be careful, subtraction is non-commutative. So D minus C is not the same as C minus D. We'll do that one in just a second. So okay, there'll be 4 take away 8, 7 take away 4, which is negative 3, 9 take away 2, 8 take away 1, 10 take away 8, and 1 take away 0. There is D minus C. Okay, I'm rushing through this because this is relatively straightforward and easy. It's just exactly what you think you should do. Just subtracting or adding corresponding elements depending on how you should combine them. Okay? So let's try C minus D then. We're not expecting the same, are we? Because we're expecting subtraction to be non-commutative, like we know that. So we're taking this matrix, 8, 4, 2, 1, 8, 0, and we're subtracting this matrix, 4, 7, 9, 8, 10, 1. So if we subtract them, would you be happy we just get 8 take away 4, 4 take away 7, 2 take away 9, 1 take away 8, 8 take away 10, and 0 take away 1. Now, clearly these two matrices are not the same, but they are related. How? Yeah, good. They're just the opposite signs, right? So you had here -4, you've got down here +4. You have up here -3, you've got down here... Ah, thank you. That's positive. Yep, 7 take away 4. Right. Fine, 3. Still the same thing here. So 7 up here and -7 down here. +7 up here, -7 down here. +2, -2, +1, -1. So the sign is different. And that should be predictable because if you think about it, if I did, I don't know, let's try 14 take away 6, what's that equal to? 8, right? But if I did the other way round, it's -8. So it's a similar kind of thing going on here because we are literally just subtracting two things from each other. Is that okay? Good, fantastic. Have we already got 2C? This one here, what do you think we're going to do here? Good. We're just going to take this matrix and multiply everything by 2. Okay, if you like, this is scalar multiplication if you think about vectors. Okay, so we should get what? What's the result? Yep. Yeah. 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 0. Perfect. Well done. Okay. What about this one? So this one's a little bit more tricky. I'd break it down into stages first. So I do 3D first. What's 3D going to be? So it'll be 12, 21, 27, 24, 30, and 3. So I've multiplied every single element in D by 3. And then I'm subtracting 4 lots of C. So I take C and multiply every element by 4. So what do I get? Yep. Yeah. 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 And 0. Perfect. So that's how I'd break down my question there. I'd break it down into 2 separate matrices, do the multiplication first. And now I can just read off what the subtraction is going to be, or the difference is going to be. So 12 take away 32. -20. 21 take away 16. 27 take away 8. 24 take away 4. 30 take away 32. And 3 take away 0. Are we happy with that? Yeah? Any queries, questions?